Starting on page 13, we're going to start with lesson 2 here, chance experiments. Go ahead and see if you can answer number 1 and 2 from section 1 there. Which one of those two things are more likely? Kellen,
Is it 1?
why?
Because if you have 20 pairs of shoes, then at least half of them are going to be left shoes.
At least half?
Exactly half.
Exactly half, yeah. 10 out of 20.
My bad. Jeez.
Half the time you should get a left shoe. All right, continue.
And then,
At least, yes.
and then when you're listening to the playlist, that would be 20% chance.
20% chance, 1 out of 5. Usually you write probability as a fraction. You could write it as a decimal. You could write it with a colon. Are usually the proper ways, and normally you reduce as well. Always, so. Number 1 is more likely, happens half the time. Now, is it guaranteed to happen? No, it's possible. If you are very unlucky that you would draw all 10 right shoes out of your closet. All right, it's possible that you would pick all 4 of the songs before you get the one you want, but it's not likely. The next problem talks about these events happening with the following options. Okay, so now we're not looking for a number, we're looking for a more accurate description, I guess. If it's going to happen, certain would be all the time, obviously 100%. Impossible would be happen 0% of the time, never. As likely as not, that would be 50% like the shoe problem that we did. And then we have likely and unlikely in between both of those. So we have a few choices here, A through J. A through J. I would like you to answer using these words, A through J. When you are done, compare with somebody next to you and see if you agree. Using those words. Once you are all done, compare, please.
Because in Alaska. Okay, I had it right.
Where's the yellow?
It's right there. Yes, I know what I was about to say. Minus three. And then,
All right, everybody compare with somebody.
All right. Let's hear how you did then. Anybody disagree? I heard somebody in the back say, well, you told me wrong and you made me get it wrong.
I was messing with it.
Oh,
Since
messing,
you
yes,
apparently
yes.
can't read.
All right. Question A. What do you think? Brooks. Unlikely. Not impossible, but unlikely. B. Brooks. Go ahead with that one.
I said likely for that one.
What do you think on that one, guys? Likely, all right. Is fast food, so it's not certain, unfortunately. C. Kellen.
I put equal.
Equally likely as not.
Yeah.
I don't think equal is a choice.
I didn't feel like writing that.
4-year-old child is over 6 feet tall, Georgia.
certain. No.
It's unlikely.
Is it possible? Has there ever been a 4-year-old over 6 feet?
Wait, there could
Unless
be.
you stretch their
They could have
spine
climbed the
out.
ladder.
Oh.
Then they're over 6
No.
feet.
Okay, unless you stretch their spine out quite a lot, probably not.
But it's unlikely.
Okay, I would say impossible because I don't think it's ever happened. There's been a lot of humans.
They could have climbed the ladder.
But if you said unlikely, you could probably argue that it is possible.
It is
I think that would be a severe genetic.
E.
Yeah.
If it's
Very
you don't even stretch.
No one in your class will be late next week.
likely.
Unlikely.
I put like.
Unlikely.
Yeah.
And then I put
Because
No.
Mr. Reeves likes to make us late.
Okay. Unlikely. Next baby born at a hospital will be a boy. Equally likely as not. Chesney, what do you think about G?
Not likely.
So unlikely?
Impossible. Can we put unlikely because of
Not impossible, it can happen.
It could happen. I don't know. Has it ever? I don't know if it's ever snowed.
Our school, not a
This literally says
Yeah.
our school.
I don't think math people go to our school. They might live in a lab.
Kinley, come on.
It did hail when I was going.
Sun will set today before 11 p.m.
That is certain.
That is certain.
Unless you live
Jonas
somewhere
put
like
unlikely.
in Norway.
Reeves live in Alaska.
Spinning this spinner will result in green.
Equal as like.
Equally likely as not. Spinning the spinner will result in yellow. You would say that, Josh.
He said certain.
Impossible.
Insert. Insert.
Impossible. All right. Evan, can I use your iPad? See if this works. iPad on an iPad.
iPad on iPad. No, we need an iPad recording an iPad. That's recording an iPad.
Students who plays the short game. I'm a great gamer. Wow. Well, I've never lost this. Except for like.
Bench dial.
All right. Here's the game we're going to play. Take a chance.
How much money are we putting on it?
I don't like taking chances.
With a partner, you will play a game of chance. In the first round, one of you will score on an even number, one of you score an odd. You decide that first. Josh, me and you are playing.
Alright, I want
Okay?
even. I
You
want
want even. Okay? So we're gonna roll. Ready? You taking even. How many times are we doing it?
5.
5 times.
Okay, that's
One.
That's
2.
Oh, she's gonna win.
That's
3.
Odd's gonna win.
Oh, I already won.
I know.
So 3-2.
I won.
No,
No,
four.
4-1. Not good. So Josh won on that one. All right, Josh, we're gonna play again.
Okay.
Second round. The winner will score on numbers 1 through 4. The other player will score on numbers 5 through 6. So if it's 1 through 4, I win. 5, 6, you win.
I
Deal?
think you're gonna.
All right, here we go.
I mean, there's a low.
I win. I win.
I have a feeling that you
It's
will win.
rigged.
I win.
Oh, darn.
Oh, you're bad at this game.
I win.
Yeah, Josh.
Oh, that's
you're
four.
so bad. Josh,
We
you're
go
good.
until I win.
I win.
No,
Get
we go
good,
until I
Josh.
win.
You already
That's
have one.
that's 5.
You won
You
one
got
time.
4.
All right. So we're gonna look at the history now. What's nice about this is we can.
6, 6.
There are all the options that happen. Okay, so what do you notice now? What were the chances if it was 1 through 6 of each number happening?
50%. Or
1 out of 6 would be the probability of each one of those happening, right? We did it 10 times. According to that, 6 should come up 30% of the time. It's basically double what it should be. Because 1/6 is what, 16%?
sure.
Okay. You only got 1/5. According to that, it should only be 10% of the time. Okay, so what was this process that we just did? That's called experiment. So that was experimental probability. What should happen doesn't always happen. You flip a coin, you should get head what percent of the time? 50%, half the time. But I could roll or flip 10 coins and it could all be heads.
It never.
Okay. It's never going to come out well, I shouldn't say never. Most of the time, it's never going to come out perfect. Okay, if I roll 6 times with the dice, I'm not going to get one number each time. It's unlikely. Okay,
We got 6.
it's unlikely. All right, the Are You Ready? Josh, would you read the Are You Ready, please?
On a game show, there are 3 closed doors. One door has a prize behind it. The contestant chooses one of the doors. The host of the game show knows where the prize is located, opens one of the other doors, which does not have the prize. The contestant can choose to stay with their first choice or switch to the remaining closed doors.
All right, this is called a famous game show problem. It's called the Monty Hall problem. Okay, the way it works, Josh just explained it. You have 3 doors. Behind one of them is the grand prize. And behind one of them they call the goat. It's a bad gift. Yeah, it might even have a goat, actually, if I think about it. So, the way it works is I say, Kellen, pick a door, and you would pick, I think it's A, B, or C. Maybe not 1, 2, or 3, I think. Door 1, 2, or 3.
I'd pick one.
Okay? So what they do is they show you this door then. They would open that curtain and then there would be 2 doors left. And then they would say, do you want to switch? They always ask the same question. They let you pick a door, they show you one that's not the grand prize and say, do you want to switch? The question is, should you switch? Okay. Mathematically speaking, should you switch?
Well,
Doesn't matter, technically.
Wayne.
All right, so first it says, do you think it matters
Yes.
if the contestant switches doors or not?
Yes.
Yes, mathematically, it does. Okay, we could play this and run through the probability of it. We are not going to. But here is what I'm going to tell you. If you are going to pick out of 3 doors, what's the probability of getting the grand prize?
1/3.
1/3.
Third chance.
Okay, you have 1/3 chance of picking the grand prize, right? So what is the probability on the other side of it?
2/3.
2/3.
Wrong one.
2/3. So right away when I'm choosing, I have a 1/3% chance. Secondly, when you choose, you have a 2/3% chance. So let's say, Kellen, you pick, just since you can see 1, 2, and 3 here, right? Pick one. You pick 2. So let's see, what would they do then?
They open the door, they let you see what's in the door, and then you can switch.
I honestly think they would.
I don't remember what they would do there. Do you remember that?
I think they.
They show you-
And then let you switch.
you the goat.
They show you the go.
Yeah, 'cause
But
then-
then you'd always switch.
No, because then you don't know.
you're right.
The one under is.
Maybe they open.
They shouldn't show you at all.
Yeah.
Maybe they, I don't know. Maybe they open yours.
I think they do.
I don't know. Let me see your iPad again.
I had the
Kellen
system,
cheated the
guys.
system.
That's a good question, Kellen.
Helen, stop breaking things.
I'm just going to Google Monty Hall problem. You can do this on your own later.
Georgia. Oh, Georgia. Yeah, I think Georgia is.
Cookie clicker.
I think I broke it.
Oh, let's play.
All right, behind one of these doors is a car. Behind each of the other 2 is a goat. So they must show you the goat then. There's 2 goats. Okay. Click on a door that you think is a car. So, Kellen, you're playing.
All right, so
3.
we're gonna click on door
3.
3.
Door 3.
I hope it's a Jeep.
Okay. Says obviously the car is not behind door 1, so they show you one of the goats, and now they say, do you want to switch if you'd like? Click on the door you think is a car. So you sticking with 3 or going to 2?
3.
Stick with it.
All right, you're gonna get
Stick
car.
with 3.
Stick with it. Goat.
Yay.
Loser.
It's not even a Jeep.
That's a shady car.
Okay. Play again. Josh, pick a door.
Let's go.
3.
Go 1.
1. I'm going to show you goat. Would you like to switch?
No.
So you're staying with 1.
Again.
Goat.
Always switch.
Okay, don't pick 2 next time.
2.
Door 2 shows you a goat.
And then 1.
Good.
So you're switching. Goat. Loser.
Wait.
I don't want that open door.
Oh, is it a scam?
No.
1.
Oh.
I'm gonna stay. 3.
Goat. 4 losers so far. Georgie.
They just
Okay,
rotate.
let's do 3.
Stan.
No, 1.
Winner.
Woo!
Is there like a strategy
Yes.
to this?
Okay, I'm gonna go with door number 2 right away.
Correct time.
Okay. I'm gonna stay with 2. Kinley?
Car.
Hey, you
Oh.
won a new car.
Oh, can I go?
Sure. Last one.
3. I'll stay.
No, it's 2.
Goat.
Oh, I'm
Watch
gonna
for
go.
it.
All right, so you can see they've had 600 players that have switched roughly. They win 64% of the time.
Wow.
About 500 people chose to stay 35% of the time. Okay? The question is, do you switch, right? Mathematically, shows you the percent of chances of winning here off of about 10,000 people playing. The moral of the story is you should always switch in this game, mathematically.
Why? How does that work?
Yeah, how does it work?
Okay?
Tell you.
At the beginning, you have a 1/3% chance, right? They show you a goat. Now, basically, you increased your odds to 50%. You had a 2/3 chance of one of those being a winner. So you increase your odds a little bit after they open one because you have a 2/3% chance or probability of the other one being a winner. Okay, so you should always switch. So if you go on that game show, feel free to give me a ride in your car or on your goat if you're not lucky.
I want a baby go.
Question 4, final question. We're going to look at two sets. You're going to describe from least likely to most likely, right? You're just going to write A, B, C, D on your paper. Least likely to most likely, these four things. All right, so here's the visual, by the way, of the other one. So at the beginning, you have a 1/3 chance of having a winner. Since they show you a goat, you know that that one's not a winner, so this one's actually got a 2/3 chance of being a winner. So you increase your odds by 33% by switching. That's a sweet goat. All right, we got this one figured out.
Even if I lose, I'll at least get a sweet goat.
Yeah.
That would probably taste pretty good.
A goat is always an option. Goat is always the answer.
All right, which letter do you got first there? Which one is the least likely? B, 10%. Next one? A, 20%. Next one? D, 50%. And 75%. So they were all basically percents. This one you had to make half into a percent. Last one?
That's a lot of reading.
You want to do this one together since it's so much reading?
No, I personally would never go do it.
Honestly, I'm down.
All right, so you just kind of make mental note of what the percent is or the fraction then, all right? First one, 2 out of every 5 dentists recommend a certain brand of toothpaste. What is the chance that a random dentist recommends the toothpaste? So what would that one be? 40% or 2 out of 5. I'd write both of those down for A. Corbin, the chance that your opponent plays rock in paper, rock, scissors. Fraction? 1/3. Percent? 33 1/3%. C, you have a pile that has 6 square patterns and you choose one. The chance that the block you chose had 4 sides of the same length. No. What? Yeah, they're square. So they are all going to have the same length. So that one should be 100%. 6 out of 6, I guess, as a fraction. Fishbowl contains 5 balls where each one has an even number 2 through 10. Even numbers. What are the chances you draw a ball with number 3 on it? Impossible. 0. There are only even numbers in there. So 0 out of 5. In general, English usage, 4 out of 25 words begin with the letter T. What is the chance that a randomly chosen word in a novel begins with the letter T? 4 out of 25. What percent would that be? 16. The probability that a certain medical test gives you the correct result is 0.95. What is the chance that the medical test is correct for a random patient? 95%. All right, so out of those 6, which one is the lowest?
D.
D should be first. And then E, 16. And then B, that was 33. Then A, that was 40. Then F, 95. And then this one was 100.
C is a low chance of you getting a C.
All right, take a look at the homework. Josh, would you read number 1, please?
The likelihood that Vaughn makes a free throw in basketball is likelihood that he makes a 3-point shot is 3.345. Which event is more likely on making a free throw or making a 3-point shot?
All right, so one is in percent, one is in a decimal. It's usually easier to compare if you make them the same. Up to you. Maybe you can see it, but be sure you explain. Question number 2, just sorting like we have done those last 2 examples. Least to greatest there. Least to greatest. Question number 3, talking about a computer programming. Which situation is more likely? A or B? And explain. Question number 4. We've done a few problems like this prior. We need to figure out total number of cups needed for 1 pizza. And then we're making 10. How much do we need for each one? How much ingredients for each one? Question number 5. Square inches of wood needed. What are we talking? Surface area or volume? Surface area.
Wait, what size is that tiny little hole?
I would say just disregard because it doesn't give us a measurement for that
Okay.
hole. Because you still need to buy the wood, you're not gonna be able to buy it like that.
That's a little bit.
Okay? Keep in mind the side piece there has a little angle on it. That's kind of what the side will look like. And the final question, put a little arrow down on the bottom there, 19. Don't forget about question 6. Select all. Select all where knowing the surface area would be more useful than the volume. Kind of a review from last unit. All right, that is it for today.